Thanks for your attention, and hopefully I'll have some questions. I'm going to try and present as questions a little bit, but I'm hoping that you can have questions at the end. I have time for questions at the end, and so be prepared to ask a few things of me. That'd be great. So what we have learned so far, we spent the last 3 lessons on a few different things. Climate change that's occurring right now is a function primarily of our fossil energy use. So this fossil energy use is this green, it's energy use in industry, energy use in transportation, energy use in buildings. This portion here is energy to produce energy. So that is our emissions, 75% about from the energy industry, our use of energy. One of the things we talked about last time, our big focus throughout the planet is the option of reducing our fossil fuel use through the use of electricity, more electricity, and electricity generated by sources that don't produce carbon dioxide or any greenhouse gas emissions. So our goal is to replace natural gas in homes and in buildings. Natural gas that would be used for cooking or heating or industrial uses, replace that with electricity, take the petroleum for our use in transportation, convert vehicles to electricity. That requires a lot of stuff. One is that our electricity demand is already increasing because of the demand in developing countries. So we're increasing our electricity demand already. And then we want to add to it this taking out of the picture the electricity produced by coal and natural gas and petroleum and put that with renewable energy, renewable sources. So trying to ramp up to increase that capacity for low carbon energy is really difficult. It's going to take a lot of electricity. There are lots of ways to do that. Wind, solar, hydro, nuclear, all those things. Lots of options available, but they all are a little bit expensive, more expensive, and a little bit cumbersome to work with because remember, having to work to match electricity supply and electricity demand at the same time. So if we're using more electricity at noon today, we have to have enough electricity capacity to meet that demand. In addition to this, so we say we can add all this electricity to the grid, build a better grid to do this. We also need to mine more minerals and things to help with that energy transition. So if we're using more batteries, we have to have more lithium, we have to have more copper. So the challenges with that are difficult. And we also talked about renewables and nuclear. All have their benefits, but they all have some negative impacts. And once again, the cost of renewables is still a challenge. It's still a little bit more than normal slides. And all right, so a question for you, just to kind of put this in a little perspective. I have a cousin who works in the trucking industry, and he is like, yeah, I would love to change our trucking industry to produce to use trucks that are more energy efficient or that are electric. Electric trucks are coming. Tesla is producing them. So trucking company A says, you know, we're going to add electric trucks to our fleet. We're going to purchase solar energy, and our cost is going to be charged to the consumer $1.25 per mile. The second company, Trucking to Win, says, you know what, we are trying to be the lowest cost provider of trucking, and our costs, we're not going to invest in electric vehicles, electric trucks. We're not going to put in solar panels. We're going to buy the cheapest electricity we can, and our cost per mile is $1. So about 25% less to go with this trucking company B. You are a producer, you are company C, and you have you're making a product and you're competing with everyone else to make that. Maybe it's bread. you're making bread and you're selling it out in the grocery stores, and you have to get it there cheaper because there's lots of other bread producers who are selling bread at cheap prices. You have a choice to make. You could either go with trucking company of the future for $1.25 or go for $1. Chances are you're going to choose the cheaper company, because if you choose the more expensive company, you're going to have to raise the price of your bread, which might cause you to lose business, right? So you're going to choose this company. And what happens if everyone is choosing this company, company B, company A is no longer in business? So the challenge with renewable energy and any increases in energy costs is that there's competition. Our world is full of competition, capitalism, and that's what happens. Unless there's regulations that require all trucking companies to have renewable energy, then it's hard for one company to go out ahead and do that. Now you could, as company C, your bread making, you could say, we're organic and we're green and we're going to charge more for our product. You can do that and then purchase this trucking company A and advertise that, but you limit the amount of people that can buy that bread. So that is the challenge that we're faced with this. Second environmental challenge that we're having, or sustainability challenge, is environmental. This is a true story. In 2012, a wind company proposed an offshore wind farm near the Netherlands, right off the coast. They spent 8 years trying to get the permit through. They finally, in 2020, got the permit approved, and within the same week, a different government agency declared that area where the wind farm was proposed and permitted as a nature zone and denied their permit. So they spent 8 years getting a permit, and then they were finally denied. So the cost for renewable energy companies to work with a cumbersome permitting permitting process, and the challenges of meeting all the environmental demands for this renewable energy are significant also. So cost and environment is always a challenge. So that's what we learned so far. That was just a little recap. I want to talk about the future of energy. So what does net zero by 2050 mean? Often you'll see it: to keep global temps from increasing more than 1.5 degrees C, we need to be net zero. The globe needs to be net zero by 2050. So what does this net zero mean? Is it that we need zero carbon emissions, like we can't emit more carbon emissions? Does it mean that there are zero greenhouse gas emissions? Does it mean that we don't use any more fossil fuels? Or does it mean that the emissions of greenhouse gases is equal to the capture of greenhouse gases? The answer is D, that we, by saying we're net zero by 2050, does not mean that we are not using fossil fuels. Unfortunately, we're going to still be using fossil fuels in 2050. It's just that we have to, whatever emissions we have of greenhouse gases, we have to capture them somehow. So we're going to talk about the capture in a second of greenhouse gas, but I want to talk just a little bit more about net zero. So the net zero is not just carbon dioxide, not just methane, but all the other greenhouse gases that go with that. So it includes all of these. The other thing it includes is that it's anytime, anywhere. So that if we're accounting for this net zero, if an airline company says we are going to be net zero, I think I use this example later, but I'll explain it now. An airline company, so individual company, not a nation, but individual company decides to go to try to get to net zero. They are burning fossil fuels in their flights, but they can then purchase carbon credits or capture carbon in some other form somewhere else, maybe even in the future, like planting trees. So in 30 years, we will have this carbon captured. So they emit 20 tons of carbon, they capture it in some other application. So it's anytime, anywhere is this net zero thing. So you don't have to be one country emitting and capturing all the carbon yourself in your country. So what this looks like in practice for the plant, for the global energy sector, so now we're not talking about land use. Remember, 25% of our emissions are from land use, but let's look just at the energy sector. And this is the plan that people have come up with to say, here's how we're going to have to do it. So this graph is in exajoules, so it's a unit of energy measurement, and it's showing this pass from 1990 to 2010. We're seeing an increase in energy use. And here's where we're at right now, about here. And it's saying that this that black is coal, this red is petroleum, and this gray is natural gas. So this is all our fossil fuels right now. This much is fossil fuels. And here it is right here. This is our fossil fuels. And it's saying our fossil fuel use is going to be down here. That's all the fossil fuels we will be using in 2050. And we're replacing, so here's our energy use up here. Our energy use, given what we're shooting for right now, we have to see some efficiency. Instead of this increasing like that, we're going to see some energy efficiency here. Oh, I'm sorry. This is our predicted energy use of the future without doing anything. This says, this gap here is saying that we want to reduce by 17% the amount of energy that we're using. So we're going to decrease our global energy use by 17% by 2050. That in and of itself is a challenge. We've talked about developing nations wanting to use more energy. So we're going to have to look at energy conservation, energy efficiency in big ways to get that 17% reduction. We're then going to take these wind, this blue is wind and solar and hydropower, and we have to increase from this amount here to this much wind and solar. So that's a 4 times, and this green is bioenergy. So if we look, let me undo this a little bit. So 17% there, and then we have basically a 5-fold reduction or increase, 5 times the increase, or 4 times the increase in renewable energy. So if we look at our renewable energy here was from the green line all the way to the top here, we're going to have 4 times more renewable energy by 2050, and we're going to have 5 times more renewable electricity by 2050. So huge changes have to happen to get us to this point where they think we can be net zero. Now, here's the question. We are still burning or using 100 exajoules of fossil fuels. So what happens with that? That is where the carbon capture comes in. So if we look at this next picture or next graph, this is in units of carbon emissions per year. And we can see the carbon emissions increasing over time. We're now at about 36 billion or 36 gigatons of carbon dioxide equivalents per year. And when we get to 2050, we're seeing this emissions drop down to here. This is our emissions. And then this part down here is this carbon capture. So we're going to take and pull carbon dioxide out of the air to get it into a form and capture it permanently. And we're going to talk about that in a second. But this is saying, this is the emissions from buildings, transportation. It's gray as transportation. The industry is the orange. We have blue and yellow from the fossil fuel industry itself. We have green, which is our building use energy. We have manufacturing, and we have production of electricity. So all of the sectors, they have it mapped out to how they need to save energy or convert to renewable energy. So there's a plan out there that people are striving for, that in the all of the global conferences, countries are committing to these reductions. So let's get into that carbon capture and storage just a little bit. So when we talk about carbon capture and storage, what it is that a power plant, say a coal-fired power plant that we're still using to produce electricity maybe, is generating carbon dioxide, and we capture off the stacks of that facility. It could be a manufacturing facility that's burning natural gas for its process. Capture the carbon dioxide from this facility and pipe it into the ground. So we're going to capture it in the ground, possibly in places where we took natural gas from the ground before, so we can seal it off underground. There's systems being set up currently all over the world to do this carbon capture and storage. It's called CCS, and it's happening. Some of these are being piped out to sea. Once again, it's where we took out that petroleum or natural gas is typically where this is being stored at. So we're planning these pipelines that will take this carbon dioxide and put it permanently in the ground. The other thing that we are doing with carbon dioxide capture, so you can capture it from plants. If you think about the concentration of carbon dioxide being emitted from a coal plant is significant. We're taking that carbon dioxide in high concentrations off the coal plant. We can also, this is called direct air capture. Direct air capture. This is a facility that's now in Iceland, and they are taking carbon dioxide out of the ambient air. So just sitting out in the middle of a field, capturing carbon dioxide, and then putting it in pipes and putting it into the ground. So it's a chemical process that we're using to capture carbon dioxide. This, if we think about it, that is also forest. Anything that's growing is also capturing carbon dioxide and putting it into the soil. The challenge with this as a storage method, storage of carbon, right? Storage of carbon is that what happens if we are planning to store the carbon here in this forest, and then we decide to cut the trees in the forest because we need that for some other purpose. Maybe we're going to be farming that Amazon jungle, or maybe we're going to be needing the trees for our home construction. So the problem with this carbon capture and storage is to make sure that it's permanent. Whatever is happening is permanent. And there's a lot of companies out now certifying that this carbon capture will be permanent. But we can absorb lots of carbon in vegetation. And so that's one of the goals. Or we do this underground aquifers, underground storage facilities for this carbon capture. So a little bit about the global thing. So anytime, anywhere, a company can be a large international company, and they can buy and sell, or they can reduce their fossil fuel use, but then buy carbon capture anywhere in the world, and that counts as net zero for that country. A company can do the same thing. Most companies have a sustainability plan right now that they're writing. I think all the leading ones, the big ones in the US, Microsoft, Apple, Nike, Tesla, any of those larger companies, Amazon, have a sustainability plan that looks at getting to net zero by 2050 or by 2030 or by 2040. So lots of options for them. What they have to do is first look at their energy efficiency. This is a step we all have to do. Number one, you look at how you conserve energy, because that's the cheapest way you can do it. If you conserve energy or do things that are energy efficient, you're reducing your carbon footprint, your energy use, so your carbon footprint goes down. And then you purchase renewable energy. So now the energy that you are using, you're saying this is going to be renewable energy. So solar panels you will install on your buildings, you will purchase solar farms somewhere, and you will reduce your carbon footprint that way. And then finally, you would buy offset credits. Offset credits meaning you're going to buy these carbon that was captured by forests, and you're going to make sure that those tons of carbon are locked up in the forest forever. Once again, it could be anytime and anywhere. So when you're thinking about carbon capture, it doesn't have to be specifically in where I'm at in Minnesota. I don't have to capture the carbon here. It could be captured anywhere. Airline industry, like I said, is a big one. They are going to continue to emit carbon. There is no good way for them to have renewable aviation fuels. Planes don't fly. Planes take a lot of fuel, and right now the cheapest and best source of fuel is fossil fuels for them. So they are using offsets to help with their carbon footprint and getting to their net zero goals. So question for you, a company uses 1 megawatt hour of electricity per year. Okay, so they're using a lot of electricity, and they know that electricity is being generated by coal plants. They say, we want to help out, so we're going to install solar panels that generate an equivalent amount of energy, 1 megawatt hour per year. Are they at net zero? They are using 1 megawatt hour and they're generating it all carbon free. It's a good question. Like, what else are they doing? This is just their electrical stuff. What else are they doing? Are their employees doing something else that involves energy? So is there electricity involved? Or I'm sorry, is there gasoline involved for driving trucks, for shipping their product? Those kinds of things have to also be taken into account. So they are not probably net zero. Could they increase this to 5 megawatt hours? So they're actually purchasing or building solar energy plants that would capture more carbon. They could do that. That would be considered an offset for them, that they could be building, helping out society by offsetting other people's fossil fuel impacts by purchasing more solar panels. It gets actually really complicated with companies. So there's a division of how companies think about their emissions. First is scope 1. So scope 1 is on-site emissions. So if you are a company and you are like an airline company who is emitting through your flying of the planes, that's one emission source. You have direct control over that. So this is direct, and we talked about it a little bit, direct and indirect emissions. This is direct emissions that you have control over right now. You have to account for those in your net zero plan. I'm using fuel at my manufacturing site. Therefore, I have to account for that carbon emissions. But you also, let's just say you're a toaster manufacturer. So you have some manufacturing things that go on at that toaster plant, that you're making parts, you're assembling parts, you're using energy on site. You might also be bringing in energy off site, maybe in the form of electricity. So you are buying electricity from a power company and they are producing emissions because they produce carbon dioxide because they're using coal. So you have to account for that off-site emission. So that's indirect. And also scope 3 emissions are all the emissions that happen. I'm buying this button for my toaster from somebody else. What are they doing to reduce the impact of this? What are the emissions from that production of that plastic button? Or the mining of this metal that goes into the toaster. So backing up the supply chain and using emissions from that, they have to account for. And as a consumer, I'm using the toaster. That toaster is using electricity. This company that makes the toaster has to account for the energy use and the carbon footprint from the consumer, me, using that toaster. Super complicated to track and to actually reduce your carbon footprint when you have all these different aspects. So once again, you have this direct emissions from the factory itself. You have stuff that's happening as you buy energy that goes into your plant. So the electricity, maybe you need steam to go in there. So you are indirectly emitting carbon dioxide there. And then all the other stuff, this supply chain and the consumer use of energy and emissions. So companies are hard, individuals are a little bit easier. I can try to be net zero. My goal in the next 5 years is to be net zero. So what does that mean for me? That means that I need to reduce my energy use, my direct energy use at home. So it's energy that comes into my house that I buy. I buy natural gas, I buy petroleum for my car, I might buy electricity. So I'm going to reduce that energy use any way I can through efficiency or conservation. I'm going to then purchase renewable energy. Right now, I have the option of purchasing wind energy, not too much more expensive than I have now. And I purchase solar energy, which then helps reduce my carbon footprint. So almost all the energy that's coming into my house right now, I am offsetting somehow. But then I have to, which is going to be a harder one, buy anything that I purchase. I should be looking at companies that produce these products net zero. How is my toaster, the company that I'm buying my toaster from, doing with net zero? Are they reducing their impact? So to really do it right, I have to do all this. So this is direct emissions, these are indirect, and these are actually indirect also. Indirect, but a little bit harder to track because I have to do a lot of research to get to understanding what companies are producing stuff with a low carbon impact. And then I can say, you know what, I am going to purchase carbon offsets. And there's a lot of opportunities to do that. If I'm not quite making it with my general energy reduction, I can purchase carbon offsets. And I go online. I just took a trip to Peru, got back a couple weeks ago. I can do a calculation. This was a flight from Minneapolis to Peru, and that calculated to be 1.84 tons of carbon dioxide from that trip. So I could look to the airline and say, how are they doing with that? Are they offsetting their carbon footprint? Or I could just purchase, and it would cost me $12 to purchase that much. It's $12 per ton, so almost 2 tons. It would cost me $24 to offset the carbon for my flight to Peru and back. So not a significant charge. Right now, carbon credits are really cheap. The actual amount is probably, instead of 12, it's closer to $40 or $50 per ton is what it should be. So I can, as an individual, become carbon neutral. So what are the barriers to this net zero? I think that's a good question. Economically, $9.2 trillion a year that it's going to cost to convert to net zero. All the grid upgrades, all the renewable energy, that is a challenge. There's politics that go along with this. So the general politics of who's going to pay for that $9.2 trillion per year investment over the next 30 years. There's politics within countries, within the US. Why can't we get to a point where we are doing more for climate change? Because of politics. Fairness between countries. Hey, we're doing our part. Why aren't you doing your part? And if you're not doing your part, why should I do my part? Or global participation. Right now, Russia could choose or not choose to participate in reducing their emissions. So that is a challenge. Logistically, we have lots to do. It's supply chain, it's building more wind turbines, it's improving the grid. Where do we get the copper? Where do we get the lithium? All those challenges. And then we have all the environmental impacts of that mining not just we have to mine, we have to have, well, there'll be impacts from that mining. So that's a challenge. Wow, that was a lot. And it ties into this last point I need to make is energy justice. Energy justice is the sharing of both burdens and benefits of our energy system. In the past, our burdens have been felt primarily, the burden of our energy system has been felt by our poor and indigenous communities. Our mining goes on in rural areas, impacting the water quality of those who don't have a lot of money. Our cities are producing lots of emissions from our vehicles, and those a lot of the poor people of the world live in these bigger cities where they're subjected to the emissions from all these the vehicle traffic. Fossil fuel extraction on indigenous lands, wind turbines on indigenous lands. How are those burdens being shared equally among everyone? And they are not right now. There's undue burden on the poor. Even energy affordability. So how much does electricity cost? Does everyone have access to electricity? The benefits then also have to be considered. The benefits would be like, hey, we have cleaner air. Where is that cleaner air? Is it in places where people are poor, or only the rich people get to live in areas with cleaner air? Clean energy jobs. Where are those clean energy jobs being generated? The mining impacts. Can we put mines in areas that are not just indigenous areas, that are more affluent areas? Can that mining happen there? And can it be done sustainably? Renewable energy projects, hydro, solar, and wind, are often in rural areas, impacting the poor indigenous people more than anyone else. So these are the challenges that we have to be considering as we do this transition. So once again, copper mining, I was just in Peru. Copper mining is a big deal. It's happening in the Andes Mountains. They want to extract more copper. It's going to impact a lot of people, native lands, indigenous lands. Where's that? This is La Guajira. In Colombia, right, you have wind farms that could produce 17% of your electricity, and they are having to be guarded because there's so many protests going on because of the location of those wind farms. Talk about nuclear. Well, we have issues with uranium mining. So how does that happen? How do we safely mine uranium, do it in places that are respective of those indigenous communities? So just so much happening, so many barriers, I think, to creating this perfect world with clean energy. One of the things, last little example, is electric vehicles. So right now, electric vehicle ownership is predominantly in wealthier countries. We will benefit because there'll be reduced traffic emissions, vehicle emissions, in more affluent countries. So the rest of the world, so this is the affluent countries, including China. China is doing really well with China's in red with their electric vehicles, but this green is the rest of the world. We are not selling electric cars, which means we don't have the benefits of better air quality in those other countries. Future summary, we have lots of energy options. Nuclear, wind, solar, biomass, geothermal, the list goes on and on. None of them are perfect. They all have impacts. We need to take a look at ourselves first, reduce our own impacts, what you can do. We need to continue to learn more, and then we need to get involved, because it will be politics that move this forward. People protesting, people writing to legislators, people being involved. So that is our challenge to all of us, to get involved, do the right thing ourselves, and then get involved.